This is Yogesh Landge, and in this video, we will see a numerical on heat transfer operation. So on the screen, there is a statement, and it is a hot gas at 325 degrees Celsius flows through a metal pipe of outer diameter 20 millimeter and the 3 millimeter thick. It is insulated with a mineral wool for reducing the heat loss in such a way that the insulation surface should not be exceed 50 degrees Celsius. Determine the thickness of insulation required, and the data is given. H1 inside heat transfer coefficient 25, H2 outside heat transfer coefficient 10 watt per meter square Kelvin, surrounding air temperature is 25 degrees Celsius, conductivity of metal pipe which is represented by K1 is 14, and conductivity of mineral wool K2 is 0.045 watt per meter Kelvin. Also calculate the heat loss per unit length of a pipe after putting the insulation. So if you see here, then the data with us, it's a temperature. The temperature of the hot gas is given. The diameter of outer pipe is mentioned here. Okay. Then the thickness of the pipe. After that one, the insulation surface should not exceed. So the surface temperature of insulation 1 is given. And the data H1, H2 and the surrounding temperature is given. The conductivity of the both the pipe as well as the mineral wool is given, that is the insulating material. And what we need to calculate, we need to calculate what is the thickness of the insulation. And the one is what is the heat loss per unit length after putting the insulation. So whatever I highlight, these are the data with us, and with the help of that one, we try to get the values of, we need to know what is the Q value, what is the thickness. Okay, one is thickness of insulation and the another is the heat lost, that is Q per unit length. So these things that we need to calculate. So with the help of the data, we will just note down the data with us, and from that one we try to get the values of it. Okay, so let's see with the help of the diagram how this numerical the statements, and on the basis of that one how it is looked. So let's consider a pipe, a circular pipe with a certain thickness. Okay, so with a certain thickness of it, and on the this one there is a insulating layer, that is the metal wool, and have certain thickness. We need to calculate what is the thickness of this insulation. Okay, so this is the pipe. We say this is the pipe, and now let's go. The data which is given, the R1 is the inner radius of a pipe, R2 is the outer radius of the pipe, R3 is the radius of insulation, T1 is the inner temperature, T3 is the surrounding temperature, H1 is the inside heat transfer coefficient, H2 is the outside heat transfer coefficient. Okay, and then the K2 is the conductivity of the insulation material, K1 is the conductivity of the metal pipe. The temperatures are given. The one temperature T1 is the surface temperature of metal, and the one surface temperature of insulating material, that is the metal wool. So this is the data with us. If I want to know the rate of heat transfer, okay. If I want to know what is the uh, the 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 resistance is here. The one resistance is by convection at this point. The second resistance is by the metal wall, means this one. Okay, so we say the one resistance at this point, one resistance by this metal wall, and the third resistance again by the conduction from the this material. Okay, and the one resistance is again there is the heat transfer between this surface to the surrounding is by air convection. Why I'm writing this three together and one the away from that one, that I will tell you later. Okay, now we can see this is the diagram. Okay, this is the representation of the what we call that is the the rate of heat transfer in this case. Okay, now let's move and see the data which is be given. We try to get write down the data. So what are the data is given? The data with us is that we have a D1, the diameter, inner diameter of pipe, D2, outer diameter of pipe, and D3, the diameter of insulating layer. So what is the diameter of pipe? The outer diameter of pipe is given 20 mm. The D1 that we need to calculate because we have the X value, the thickness that we know. The thickness of the pipe is given 3 mm. So on the basis of that one, I can easily calculate the diameter, outer diameter of the pipe minus the 2 times the thickness. So what is the outer diameter of pipe is 20. Okay, minus the 3 multiplied by 2. So 3 multiplied by 2. So we got the inner diameter is 14 millimeter. Okay, now D3 that we do not know because that we need to calculate because the data is not mentioned. So we convert this into the radius one. So R1 is 7 multiplied by 10 raised to the power 3, that is the in meter. R2 value which is be a 20. So 20 divided by 2 is 10. So 10 raised to the power minus 3, that is in a meter. And the R3 value that we need to calculate. We do not know what is the value of R3 and that we need to calculate. Apart from this one, that the data with us is that we have a data of temperatures. So T1 temperature is given 325. T3 temperature is given the surrounding temperature 25 degrees Celsius, and the temperature at this surface means the value of T2 is given 50 degrees Celsius. Apart from this one, the H1 value inside heat transfer coefficient is given, which is the 25, and the this one, H2, which is be given a 10. Okay, it is in a watt per meter square per degree Celsius. Okay, apart from this, we have the data of K1 conductivity of the metal, which is be a 40, and the conductivity of the insulating material, which is 0.045. Okay, this is in a watt per meter degree Celsius, watt per meter degree Celsius. So this is the data with us, and with the help of this data, we try to know what is the value of the X, that is the thickness. So here, what we need to calculate, we want to find what is the thickness of this insulation if the surrounding temperature is 25, surface temperature is 50, conductivity K2 which is 0.045. Okay, on this case, let me know what is the thickness of this one. Okay, so here as I said earlier, that is there is the convection part, the heat transfer between this one by convection, through this one is by conduction, through this one is by conduction, and then from this to this is by a convection one. So we correlate this part. We say that there is a steady state condition, and on the basis of the steady state condition, let's check what is the value of Q, because here we do not have a data of Q. We don't know the Q. If we know the Q, then directly we can get the value of R3. But now we do not have, and that's why we have to just do the calculations on this basis. So how? Let's check it. So let's see here. The formula with us is this one. So this formula is used. Okay. So this formula that we can use for the resistance at the starting R convection plus resistance by the metal pipe plus resistance by the insulating material plus resistance by the convection, that is the surrounding from surface to the surrounding one. So this is the formula, and here we can write here this one, the first case where we say it is by the convection, conduction, conduction and convection. Okay, now what we do, we just add these two 3, we just make this together, this one together, and 1, this is. We equal this one because here is R3 and here is also the R3. And because of that one, what we do? We just correlate this one, and on the basis of that one, we try to get the value of R3. And we just say this is the Q total is this state at the steady state condition, this value, as well as from this one is the same. Now here we write a formula directly. So we split up this one, we write in terms of Q. The Q is equals to the 2 pi L T1 minus T2, the inner temperature and the surface temperature of the insulating material. So heat transfer at the inside, heat transfer to the metal wall, and heat transfer from the metal wall to the insulating material up to the surface. So we write down the values of it. So what is the value of it? So 2 pi L, which is a constant one. So I put it as it is. The value of T1 is given 325 degrees Celsius. Value of T2 is given 50 degrees Celsius. So I just put it that values all. Divide by 1 upon the H1 value. What is the value of H1? H1 is 25. I put 25 multiply by the R1 value. R1 is given, it is a 7 millimeter. So we can write 0.007 plus ln of R2 by R1. So what is the value of R2? R2 is here, which is the 10. Okay. So 10 millimeters. So we can write 0.01 upon the value of R1, which is again 0.007. Okay, just write it plus ln of R3. We do not know the value of R3. R2 we know it is 0.01 upon the K2 value. Sorry, here is I miss out the K2 value. What is the value K1? K1 is here is it is 40, and here the K2 is 0.045. So this is the first case that I have write. The second case is that from this one, I am writing from this one, it is again 2 pi L into the T2, the surface temperature of the insulating material minus the surrounding temperature 25 divided by it is 1 upon H2 value is given, which is the 10, multiply by R3. We do not know the value of R3 because we need to calculate. So here R3 is here and 1 R3 is here. So we equate these two equations. So this and this one. Okay. So we say this is at the constant one. On the basis of that one, we just equate these two equations. Okay. So we equating on when we equating this equation and this equation, then the common term is this one, just we cancel it, so there is no confusion at all. And then we are writing the values of all this one and try to get in a simple form. So for the simplification, what we do on the basis of that one that we have, okay. So what we have, we write it as 325 minus 50. Okay. Oh, sorry. So directly I just write it, that is 275. Okay. Upon the after the calculation of the all this one, we got values is 5.714 plus a negligible value 8.91 into 10 raised to the power minus 3 plus ln of R3 by 0.01 divided by 0.045. Okay, this values that I write now, that is equals to the next term, which is b 50 minus 25, it is 25 divided by, it is 1 upon 10 times R3, because R3 we do not know. So we don't know the value of R3 which we need to calculate. So it is there. So after doing all the calculations, we just move it again in a simple form, 275. I just add these two which is the negligible one, and we got value is 5.722 plus this term. Okay, it is ln of R3 by 0.01 upon 0.45. Okay, this is the value that is equals to the, so this term is equals to the 25 by 1 upon 10 times R3. Now what we do, we just take this term this way to here in this side and this one at this side. So we just do that one. So we just write 275 divided by 25 into, as I'm taking this one this side, and it is 1 upon 10 times R3 is equals to this is just a simplification one I'm doing, 5.722 plus ln of R3 value, which is don't know, divided by 0.01. Okay, now upon, sorry, upon it is 0.045. So this is the case. Now we try to get the value of R3, and for that one, again after the simplification of this one, we just write down directly the formula, which is 275 by this one is 11, so by 10 in bracket 1 upon R3, which is equals to the 5.722 plus ln of R3 by 0.01 upon 0.045. Now what I do, I just do the simple multiplication and take some common terms of that. So I just repeat it, the case 11 by 10 1 upon R3 is equals to the, I just do the multiplication of these two so that I get the in a simple form 2575 plus ln of R3 by 0.01 and whole divided by 0.045. Okay, so 0.045. After this one, what I do, I again multiply this 0.045 to this term. Okay, and simply that I got the values of it, which is the 0.0495 divided by R3 from, I just do this one. Okay, this one multiplication is equals to the 0.2575 plus ln of R3 divided by 0.01. Now I just take this term at left hand side, so I write 0.0495 divided by R3 minus ln of R3 by 0.01 is equals to the 0.2575. Now on the basis of the trial and error method, I try to get a value of this R3. I try to get the value of R3. How I get? On the basis of trial and error method. So as we know that the outer diameter of pipe, what is the outer diameter of pipe is 20. So obviously it is more than that. So or the radius we can say R2 radius is 10 mm. So obviously the insulating layer is more than that one. So I started from the 11. So if I say I go with the 11 one. This 11 mm. Okay, this is in mm. This is the radius. Okay, at that time I got the value is 0.4047. What we just correlate the left hand side is equals to the right hand side. So what is in the right hand side? It is 0.2575. 0.2575. So I want to the same value by putting the R3. Okay. Now this is the value of R3 on the basis of the trial and error method. Trial and error method. I just try to get that values. Okay. So then I move for 0.20 mm. Again check it. Now I got the value is 1.79. So accordingly I just do the one. I put it 20, then it is only 1.78. So far away. So I directly move for the 30. I found it nearer to that one, but again it's have the problem. Then I move slowly with the 33.7. I got value is around 2539, so which is almost nearer to that one. And even if I do the fraction of it 33.6%, then exactly I got this value. So I just chooses this one because I don't want to do the more accurate calculations. It is okay for on the calculator because this is Excel sheet that I generated, and that's why I got all the fractions. But now okay, we go with this one because first two terms is there 25. Okay, and nearer to that one. Okay, so I just take the value is 0.0337 for our calculations. So with the help of the trial and error method, we found the value of R3 is almost around 0.0337. If we see this is again the almost the same one 0.03365. So it is round up to the 7. So it is almost the same value. Okay. Now the question is we need to calculate what is the value, what is the thickness. We are interested to know the thickness. Till we calculate only the radius. Now we know that the thickness of the insulation is equals to the how much? We can write it is as the R3 value, the thickness of insulation, the radius of insulation minus the radius of the outer pipe. What is the thickness that we calculate? It is 0.0337, and the radius of this one is 0.01. So on the basis of that one, we can say the thickness of insulation X1 we can say, which is be around 0.0237 meter, and if I want to convert into the centimeter, sorry, into the millimeter, then it is 23.7 millimeter. So this is the thickness of the insulation. So this is the first answer. Now we move for the next one, that is they ask what is the value of Q by L, that is the amount of feet loss per net length. And for that one we use the formula of Q equals to the HA delta T. So we say that this is the surrounding, okay, surface of the insulating material, and from that one the heat is losses to the to the surrounding. Okay, so on the basis of data that we know the value of R3, we know the surface temperature 50, we know the surrounding temperature 25, that is T3 value, and it is T2. Okay, also as the H value is also given, the H2, the surrounding heat transfer coefficient is given, so we just put it that values. So we simplify this equation as H is into 2 pi R, and this R is 3 because the radius of the insulation, into L multiply by a temperature, which is the temperature of the material, insulating material, minus the surrounding temperature. So we write the value of H is given, which is the 10 in the data, into the 2 into the pi value, which is a constant, R3 value which we calculated, it is 0.0337 multiply by L. L I am taking this side, so Q by L, because we are interested to know the value of Q by L, into the temperature is 50 minus 25. Okay, so once we do the calculations of this, all this one, and after doing the calculation, so we got the value of Q by L is equals to the 52.93 watt per liter. So this is the second answer. So we got the value of R3 is 0.0337. From that one, the thickness that we calculated, which is be 23.79 mm, and the Q by L equals to the 52.93 watt per liter. So these two are the answer of the question. Thank you.